Hello everybody, my name is Afiq Azali. Today I will talk about our project, Solar Tracking System. Before I introduce my project, let me introduce my team members. We have Mansan Mehta as our group leader, Anali, Mohit Patel, and our advisor, Dr. Al Turkey. The goal of our project is design an automatic system that can rotate the solar panel to the sun to perpendicular to receive a maximum energy conversion. There's a major problem with the solar panel right now. We take only 15 to 20% advantage because we have a stationary solar panel. Wherever you go, you have a stationary solar panel. So because of the sun rise from the east to west and north to south. If you see in this table, if we are perpendicular to the sun, we don't lose any power. But if you're 45 degrees away from the sun, we lose 30% power. The further away we go from the sun, we lose more power. So we want to improve the solar panel system to make sure we maximize the energy conversion. If you do that, a lot of people right now they're using petrol, gas, the other alternative power source. They make a lot of pollution in the environment. If they start using the solar panel, it will be clean and renewable energy. There's three different methods we can solve this problem. The first one is a global positioning system, the GPS tracking system. Does require another communication system all the time, and sometimes it's not accurate, and it's very costly. The another one is the dome shape. The dome shape, you need the solar cell all the time on the dome. So most of the time, all the solar cell is not charging, and solar cell is very expensive. The third one we'll pick is the light sensor system, the automatic system. We're using a photoresistor. It's very low cost and it's very accurate to track the sun. Let me talk about our project overview, how it works. So mostly we connect the solar panel and the light sensor system. The light sensor system connects to the solar panel. Light sensor system detect the sun, send the signal to microcontroller. Microcontroller be programmed and to take an input from light sensor and give an output to our gear motor system. And the gear motor system rotates the solar panel perpendicular to the sun to receive a maximum energy. To charge the battery, we're using a charge controller between solar panel to the battery not to overcharge. The battery, we're using a voltage regulator to make sure we supply exact 12 volts to our system. And we're using a DC to AC inverter to use a small electronics from the battery. We have 5 technical design constraints: the light sensor system, gear motor system, microcontroller, controller, and testing. I will talk each one in the next future slides. Non-technical design constraint. The material is very important to us. We want to make sure we research before we buy anything because we have only a limit of $500 and our project is less than $500. And we also want to make sure we are up to our schedule, make sure we meet our schedule deadlines. And advertising will be easy because our solar panel can contain 40% more energy than compared to the whatever solar panel is in the market available right now. Usage, you can use anywhere, wherever the sun is. You just go, you put our tracking system, and you can start using our system. The solar panel is the first important thing we need. The solar panel we are using is 11 pound and it has 36 collection. Each cell gives us 1.25 watts. That's a total of 45 volts. To take that power, we're using a 12 volt universal battery to charge the battery. The photoresistor is a light dependent register. It's a variable register from 1 to 5K. It's very easy to use with an Arduino microprocessor. Let me explain you how our light sensor works with the photoresistor. So we have a disc on the solar panel. So we put a pole in the middle of the disc and then put the 3 photoresistors on the left hand side and 1 on the right hand side. The disc can rotate 360 degrees. So when the disc rotates, we detect the 3 shadows, photoresistor. that means we have to turn the solar panel 180 degree. Now we have only one photoresistor is detected. This time we just tilt our solar panel toward the sun. When there's no shadows detected, that means we are perpendicular to the sun. And when we are looking for when the disk is moving, and if we detect only one photoresistor, that means we just have to tilt. We don't have to tilt 180 degree to go and back and forth. We just tilt it and go to the perpendicular. The microcontroller is the brain of our project. Mostly that we take the signal from our light sensor system and we give an output to our gear motor system to operate. The gear motor system, we're using two different kind of motors. We're using a DC servo motor, continuous, and the standard servo motor. Standard servo motor can rotate 180 degree, and the continuous is 360 degree. For example, if we have a sun over here, the continuous motor can rotate any angle, and the standard motor can tilt up and down. So it doesn't matter where the sun is, we are just tracking the sun. We did a simulation for our control system because microcontroller give only 5 volts output. So we're using a non-inverting op-amp to make sure we have enough power for our motors to run. So it's like 12 volts. Right? So photoresistor, how do we know when photoresistor is at? It's a variable register from 1K to 5K. So mostly when we put the photoresistor series with another register, use the voltage divider rule to find out. Like mostly when it reaches to 5K, that means the photoresistor is high. So that's the only time you send a signal to microcontroller. Otherwise, you don't send any signal to microcontroller. We also did some basic programming to understand the relationship between Arduino board and the servo motor. We wrote down the basic code, how servo moves. So mostly we connect my servo motor to Arduino board and write down my servo write 0. That means servo rotate clockwise for 4 seconds. When I write down 180, it's counterclockwise for 4 seconds. If I write down 0, it do not do anything. So this is just a basic relationship to understand how the Arduino works with the servo motor. A design cost is only $486, but if you notice, the light sensor detecting system is only cost $70 compared to dome shape and the GPS costs a lot of money. Schedule. So far, we researched our product, we understand the project, we get the calculation, we found the torque. Now we just have, and we finalize. Now we just have to ask the permission from our advisor to order the part. But we also, after we receive a part, we have to start building our project, and then from that we look for the sponsor, and if we find the sponsor, it's good. And after that, we mostly just do a lot of testing to understand what's the problem. And if we find any problem, we make sure we fix our senior design paper and make sure to update all the correct information on it. There's a major technical challenge. Like we have to make sure, first thing we have to figure out how big pole we need on the disk. And then how we determine how to send the signal. So from a microcontroller, we have to understand exactly how to, the light sensor, when we detect the light, light sensor system have to send the signal to microcontroller. Microcontroller have to send a signal to our gear motor system. So we have to understand exactly how to program it. When we understand that, we also have to give a power to our gear motor system. So we have to make a circuit for that. And if we do all this thing, I think we will achieve our goal. And nobody did this thing before. This is the first time anybody did the light sensor system with the pole. And thank you for listening to me. And mostly that's about it.
Questions? Any questions?
Yes.
Sure. Why is it rotating only 180 degrees?
Like, for example, right here, it's rotating 180 degrees because it detects 3 photoresistors. So that means the sun is on the opposite direction. So mostly it rotate 180 degree. Now we have only one photoresistor is detected. So this time you only have to tilt until there's no shadow is detected. So if there's no shadow, that means we are perpendicular to the sun. So it'll always charge.
The 180, I believe, is in the morning, right?
Yes, like for example, sunrise and go down, and our solar panel direction is still there, the other side. Sunrise over here, we get the shadow. So we rotate 180 degree, and then it just tilt it, and then we are perpendicular to the sun. Yes.
So if I want to buy that device, how much is going to cost me on the store if it's all done?
Like the solar panel is getting cheaper every day. The more research the people do, they get a lot cheaper. So for right now, we have 486. That's where our price is, but it might go cheaper. The main cost is the solar cell. Solar cell alone is $150.
So if I go to Best Buy one day, $500, I get one, right?
Yes.
Yeah, can you go back to block diagram? See, between solar panel and battery, you are using a charge controller to prevent the battery to overheat. So let's say in a whole day, the battery charge between the half day. So what are you doing, the power your solar panel producing after the half day?
Like this is, we're just showing only one battery, but we can put as many batteries. When after this battery is charged,
Oh, okay.
we can transfer to another batteries,
Oh,
more
okay.
batteries.
Because you're saying by rotating the solar panel, you make it more efficient, but I'm just putting one battery.
Now you can put as
That's
many
why I was
batteries.
wondering. Oh, okay, you can put as many battery you
Yes.
Oh,
When it's one battery is charged, we can move to another battery.
oh, okay.
I have a question. What happened at night?
Nighttime, because like right here, all of the photoresistor is on or off. When all of them is off, that means it stays the same position. It do not move. So it detects the shadow. So when we have, for example, right here, when we are perpendicular to the sun, there's no shadow. That means it's a dark.
Right.
As soon as we have a shadow on our panel, on the disk, so it rotates, it fixes it by itself. So mostly we're using a 0 or 1. Whenever it's high, so don't do anything. When it's low, look for the high signal.
Also, the other question is, how much torque do you need? Have you done the calculation?
Like we did the calculation, we found out the torque, how much torque we need.
Was it really enough for the small motor you have?
Like the thing is, like right now we found the torque, we did the calculation to find the torque. Now we have to go on the website, look for the manufacturer, like what motor is good for us, what size motor we need. That's how we still have to finalize this and get the permission from Factoral Turkey to make sure we order that motor.
Questions?
How are you driving the motors? With a pulse width modulation or amplifier?
We're using an amplifier.
Okay, but you showed the Arduino with PWMs, right?
This is just a basic code to understand the coding, how to work with the servo motor, the relationship between servo motor. We just wrote down basic code. This is not the actual code we are using for our design.
More questions? Okay. If you have a perfect tracking, how much power you can produce compared to stationary tracking?
We'll be 40% more than what they're right now. 40%.
40%.
Mhm.
Okay. Now, if you have like a row of solar cells, you are not really going to attach like a motor for everyone, so you have a motor for the whole thing.
The whole thing, yes.
So
So the total weight of the solar panel, and then our motor is based on the weight. The more weight, the more torque you need. So mostly every solar panel have a different motor. If you have 11, like 15 pounds.
No, I mean, suppose that you have identical solar panels in a row, and they are all tracking the sun. So you will need like one motor only, or maybe
Yes.
one big motor
Big one
to
motor.
just move all of them
Yes.
at the same time, right?
Mhm.
So did you discuss that, or?
Yeah, we are using two different motors. One on the bottom, one on the top.
That's for one, right? Just for one.
That's for whole panel.
Yeah, but suppose that you have a row of solar panels, like a farm.
Like a farm?
Yeah.
Like you're using a one motor, the one big motor to
You use
rotate?
one big motor?
Yes, mostly is perpendicular to the sun.
So you'll be able to calculate the torque as the torque.
Yes, we did calculate the torque. We just now we have to figure out exactly which motor is good for us to buy.
Okay. Any more questions? Okay, thank you.